All right, students, with these group of questions, or this group of questions, we have an interesting thing happening. Again, I think this is in lesson 4 or lesson 5. It says, create another equation that also represents the area and is based on the closest perfect square. And then it reminds you, you won't get reminded of this if you have this question on a test, but it reminds you, find a GCF that you need to factor out of the first two terms. The reason why is, remember our last video, and also we've been learning in class, that when you complete the square, we're going to ignore this minus 2. We're going to kick it down the road. We'll deal with it later. We want to know, what does this number have to be in order to make a perfect square? And in these cases, when you look at those first two terms, and you ignore the negative 2, there's a common factor here, a greatest common factor. Now, you don't want to factor out an x. You want to leave that there. But you do want to factor out the 3, and just think about this. It's kind of like our story of optima prime. They're not actually getting an order for one quilt square. They're getting an order for 3 of them. So we're going to factor that out. And let's figure out what's left over. We have to figure out, how do we factor out the 3 and get back to where we started if we redistribute? So 3 times x squared is going to get us back to 3x squared. And 3 times 4x is going to get us back to 12x. And now we're going to go ahead and figure out, what do we need to do in order to make a perfect square there? And again, we'll deal with this negative 2 or this minus 2 later. So this is the part we're focusing on. Same rules as before now. We already know we have an x squared. And we know we have 4x now, which means we divide it by 2, so we can split it equally between these two spaces, the upper right and the lower left area. In fact, in this case, class, you already know what the side lengths are. This is going to be x times x is x squared. This is x times 2 is 2x. And this is x times 2, which is 2x. This proves that we made a perfect square. And now we have to figure out, what number do we need to add into this lower right-hand corner? This is not part of our equation. Everything else you've done so far is in that equation. In fact, class, we should actually do this. There are 3 of these, 3 times these actual squares. And sometimes I'll put these in parentheses to show you that we've got 3 of these quilt squares that we are making. So again, what number do we have to add to make this a perfect square? Well, that's easy. The dimensions of this lower right are 2 times 2, which is 4. And that means we have to put a 4 here in order to make this into a perfect square. Now, the difficulty is, or the twist is that you didn't just add 4. You can't just put plus 4 here. Because if you look at, minus 4 here, because you added 4 here, but really you added 4 to all 3 quilt squares. 3 times 4. You can see it here algebraically. 3 times 4. So you're going to subtract 3 times 4. And now let's go ahead and write our final equation. It's pretty easy. Let's change this to a color that's different. I'll use this color. So I'm going to have A, see if I have room for this. A of x is equal to, we've got 3. And if you look at this, we've got 3, and our side lengths are x plus 2 and x plus 2. That's actually changing this x squared plus 4x plus 4 to x plus 2 times x plus 2. And now the question is, what do we put on the very tail end? And it's going to be this number right here, negative 2 minus negative 3, minus 3 times 4, which is negative 2 minus 12, which is negative 14. Negative 14. Hang on one second. There we go. So we've got minus 14 right here. And there's our final equation. And that's all there is to it, class. So you just got one extra step here. You got to deal with this 3. You don't want to be dealing with this 3 inside of your quilt square. You want to take it out and say, well, there's 3 of these. Here's our 3. Here's our quilt square and written as a factor of 2. Sorry, this is written as the closest perfect square, x plus 2 squared. And then we got to deal with this minus 2, which was over here. And then we realized we didn't add 4. We added 3 times 4. So there is your leftover number that you put right there. I'll put that in a box. See if I can do that. There we go. All right, let's do the next one. Basically, same routine. So we look at this and say, well, we don't want to actually create the closest perfect square if we've got a 5 hanging out here. So we're going to actually group these 2 together. And let's leave this plus 6 for later. Now we're going to factor out the 5. So we've got 5. And what do I have left over? I have to figure out, class, what goes in this binomial that when I redistribute the 5, I go back to where I started. I don't want to modify this equation. I want to rewrite it in a different form. So this is 5 times x squared, and then 5 times negative 8. Is that 8? 8 times 5 is 40. Yep, so this is minus 8. And then we're going to go ahead and put a plus something because we have to figure out how we're going to complete the square. And then we're going to have this, this leftover showing up over here. So here we go. Let's complete the square. So far, class, again, think about this. Everything I've done so far hasn't changed this equation at all. I haven't added or subtracted anything from it. It's the same exact equation. Here's our 5 times x squared minus 8x. There's your 5x squared minus 40x. And our plus 6 is showing up over here. Let's go ahead and complete the square. So inside our parentheses, here's my quilt square right here in the parentheses. I've got x squared. Negative 8x divided by 2 is negative 4x. And negative 4x. And that means our side lengths are actually going to be x times x is x squared. X times negative 4 is negative 4x. Same thing over here, otherwise it wouldn't be a square. And now what you've done so far, class, is you've actually written this equation, 5 times x squared minus 8x. We got to figure out what number do we have to add to this. Now we're actually modifying our equation. We're going to say negative 4 times negative 4 is 16. That means we are adding 16 to this square block. And if we add 16, we have to subtract 16. But we didn't actually add 16, class. We added 5 times 16. I'm looking for my calculator right now. So if we look at this, we actually added 5 times 16, that means we have to subtract 5 times 16. Let me check that. 5 times 16 is equal to 80. So this becomes plus 6 minus 80. And 6 minus 80 is negative 74. So here's what we have. We have this minus 74. Let's do this. Let's just rewrite our equation. A of x equals 5. Here's our perfect square that actually is the same. X minus 4 squared is the same as x squared minus 8x plus 16. So I've got x minus 4 squared. And now we're going to go ahead and subtract 74 from that. And there is our closest perfect square. Whoops. Class, I'll let you know, if you graph either of these equations, the original one or the new one, they will graph exactly the same because we kept it in balance. We had to add 16 here, so we added 5 times 16, which was 80. So we have to subtract 80 from this leftover, and there's what we have at the end. Perfect square and the leftovers. That's 24.